In the vast expanse of our cosmic backyard, a silent threat orbits above us, hidden in plain sight. It's not a tale of distant galaxies or alien invasions, but rather a crisis of our own making, space junk. As we look to the stars with dreams of exploration and discovery, an ominous cloud of debris looms, casting a shadow over the future of space exploration. Join us as we delve into the depths of this celestial dilemma, exploring its origins, unveiling its risks, and discovering the innovative solutions that could shape the destiny of our cosmic aspirations. In the vast expanse of the cosmos, human activity has left a trail of debris scattered across the heavens. This debris, often referred to as space junk, encompasses a wide array of objects, from defunct satellites to discarded rocket stages, and even smaller fragments resulting from collisions and explosions. As humanity's reach into space continues to expand, so too does the accumulation of space debris. With each new satellite launched, each rocket stage jettisoned, the risk of collisions and the proliferation of space junk grows ever more significant. This burgeoning cloud of debris poses not only a threat to existing space infrastructure, but also to future missions and even the safety of astronauts themselves. The urgency of confronting the space junk crisis cannot be overstated. As we venture further into the cosmos, our ability to navigate through space safely becomes increasingly imperiled by the presence of debris. Failure to address this issue could not only hinder our ability to explore and utilize space, but could also lead to catastrophic consequences for both spacefaring nations and the burgeoning commercial space industry. Among the most prominent contributors to the space junk crisis are defunct satellites. These relics of past missions, once useful instruments of exploration or communication, now drift aimlessly in orbit, serving only as potential hazards to operational spacecraft. Another significant source of space debris is the spent rocket stages left behind after launching payloads into orbit. These discarded components, while essential for the initial propulsion of spacecraft, often remain in orbit long after their usefulness has expired, adding to the clutter of space debris. In addition to intact satellites and rocket stages, space debris also includes countless smaller fragments resulting from disintegration, collisions, or explosions. These fragments, ranging in size from tiny flecks of paint to larger pieces of metal, pose a significant threat due to their potential to cause damage upon impact with operational spacecraft. The extent of the space junk problem is staggering. According to recent estimates, there are over 9,000 tons of space debris orbiting the Earth, with tens of thousands of individual objects larger than 10 centimeters in diameter and millions more smaller fragments. This dense cloud of debris presents a formidable obstacle to the safe navigation of spacecraft and satellites. The presence of space debris has profound implications for space activities and infrastructure. Not only does it increase the risk of collisions with operational spacecraft, but it also poses a threat to critical infrastructure such as communication satellites, weather satellites, and scientific instruments. Additionally, the proliferation of space debris complicates future space missions, requiring careful planning and mitigation strategies to ensure the safety of astronauts and spacecraft alike. The origins of the space junk crisis can be traced back to the early days of space exploration, marked by a series of historical events that have left a lasting legacy of debris in Earth's orbit. These events include the launch of the world's first artificial satellite, Sputnik 1, in 1957, and subsequent missions that followed, each adding to the growing accumulation of space debris. One of the primary drivers of the space junk crisis is the continued launching of satellites and spacecraft into orbit. With each new mission comes the deployment of additional hardware, adding to the already substantial cloud of debris encircling the Earth. Compounding the problem is the practice of satellite disposal, or lack thereof. Many satellites, once they reach the end of their operational life, are simply left in orbit, contributing to the buildup of space debris over time. While some efforts have been made to deorbit satellites at the end of their missions, these practices are not universally adopted, further exacerbating the space junk crisis. Perhaps the most alarming cause of space debris accumulation is the occurrence of collisions and breakups in orbit. When operational spacecraft collide with existing debris or with one another, they often disintegrate into smaller fragments, adding to the overall density of space junk. These collisions can occur accidentally or as a result of intentional actions, such as anti-satellite weapons tests, further destabilizing the space environment. The proliferation of space debris poses a significant threat to the operation of satellites and spacecraft in Earth's orbit. With thousands of objects hurtling through space at high velocities, the risk of collisions with operational hardware is ever present. Even a relatively small piece of debris can cause catastrophic damage to a satellite or spacecraft, rendering it inoperable and potentially creating even more debris in the process. The presence of space debris also presents a grave danger to crewed space missions. Astronauts aboard spacecraft are at risk of being struck by debris traveling at speeds of up to 17,500 miles per hour, which could puncture the hull of their vessel or damage critical systems. In the event of a collision, the consequences could be dire, potentially resulting in loss of life or the need for emergency evacuation. The International Space Station, ISS, humanity's only permanent outpost in space, is particularly vulnerable to the threat of space debris. Orbiting at an altitude of approximately 400 kilometers above the Earth's surface, the ISS regularly encounters debris that poses a risk to its structural integrity and the safety of its crew. Even a minor impact could puncture the station's hull, leading to depressurization or other critical failures. Beyond the immediate risks to human life and infrastructure, the space debris crisis also carries significant economic implications for the space industry. The cost of mitigating the effects of space debris, including tracking and monitoring existing debris, implementing collision avoidance measures, and developing technologies to clean up orbital debris, represents a substantial financial burden for space agencies and commercial space companies alike. Moreover, the potential for damage to satellites and spacecraft threatens the viability of space-based industries such as telecommunications, Earth observation, and navigation, further exacerbating the economic impact of the space debris crisis. Recognizing the urgent need to address the space debris crisis, the international community has developed a framework of guidelines and agreements aimed at mitigating the generation of space debris and minimizing its impact on space activities. These include guidelines established by the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, such as the Space Debris Mitigation Guidelines, which outline best practices for the design, operation, and disposal of spacecraft to minimize the generation of debris. Despite the existence of international guidelines and agreements, enforcing and enhancing space debris mitigation measures remains a significant challenge. Compliance with these measures is voluntary, and not all spacefaring nations or commercial entities adhere to them consistently. Additionally, the rapid pace of technological advancement and the proliferation of space activities present ongoing challenges in developing and implementing effective mitigation strategies. Addressing the space debris crisis requires collaboration among space agencies, private companies, and international organizations. Space agencies play a crucial role in developing and implementing space debris mitigation measures, including monitoring space debris, coordinating collision avoidance efforts, and promoting the adoption of best practices among spacefaring nations and commercial operators. Private companies also have a responsibility to mitigate the generation of space debris through responsible spacecraft design and disposal practices. Furthermore, international organizations such as the United Nations and its affiliated bodies provide a forum for coordinating efforts to address the space debris crisis, facilitating dialogue among stakeholders and fostering collaboration on research and technology development initiatives aimed at mitigating the risks posed by space debris. By working together, space agencies, private companies, and international organizations can pool their resources and expertise to tackle the space debris crisis effectively, ensuring the long-term sustainability of space activities and preserving the viability of future space exploration endeavors. In response to the growing threat posed by space debris, researchers and engineers have developed innovative technologies for actively removing debris from orbit. These include concepts such as robotic arms, nets, and harpoons designed to capture and deorbit defunct satellites and other large pieces of debris. By actively removing debris from orbit, these technologies help reduce the risk of collisions and mitigate the proliferation of space junk. Another key component of efforts to address the space debris crisis is the development of advanced tracking and monitoring systems capable of accurately cataloging and predicting the movements of space debris. These systems utilize a combination of ground-based radars, optical telescopes, and space-based sensors to track debris in real time and assess the risk of potential collisions with operational spacecraft. By providing timely and accurate data on the location and trajectory of debris, these systems enable spacecraft operators to take proactive measures to avoid collisions and minimize the risk to their assets. Sustainable satellite design and disposal methods are essential for mitigating the generation of space debris. Engineers are exploring innovative approaches to designing satellites with built-in mechanisms for deorbiting at the end of their operational life, such as solar sails, electric propulsion systems, and lightweight inflatable structures. Additionally, efforts are underway to develop alternative disposal methods, such as using aerodynamic drag or gravitational perturbations to accelerate satellite deorbiting without the need for additional propulsion. Addressing the space debris crisis requires collaborative efforts involving governments, space agencies, private companies, and international organizations. Initiatives such as the European Space Agency's Clean Space program and the Japan Aerospace Exploration Agency's KiboCube project bring together stakeholders from around the world to develop and implement innovative solutions for cleaning up space debris. By pooling their resources and expertise, these collaborative efforts accelerate the development and deployment of technologies for removing debris from orbit, helping to ensure the long-term sustainability of space activities. As humanity continues to push the boundaries of space exploration, the space junk crisis looms large as a significant obstacle to future missions. The presence of debris in Earth's orbit poses a constant threat to spacecraft and satellites, increasing the risk of collisions and potentially jeopardizing the success of upcoming space missions. Without effective measures to address the space junk crisis, the viability of future exploration efforts could be severely compromised. In light of the challenges posed by the space junk crisis, there is an urgent need for sustainable space practices to ensure the viability of future exploration. This includes designing spacecraft with built-in mechanisms for deorbiting at the end of their operational life, implementing robust tracking and monitoring systems to avoid collisions with debris, and actively removing existing debris from orbit. By adopting these sustainable practices, space agencies and commercial operators can minimize the generation of space junk and preserve the integrity of Earth's orbital environment for future generations of explorers. Finally, ensuring the long-term sustainability of space exploration requires encouraging responsible behavior among all stakeholders involved in space activities. This includes promoting adherence to international guidelines and agreements on space debris mitigation, fostering collaboration and information sharing among spacefaring nations and commercial operators, and raising awareness of the importance of preserving Earth's orbital environment. By working together to promote responsible behavior in space, we can pave the way for a future of exploration that is both sustainable and prosperous. The space junk crisis represents a significant threat to the future of space exploration. With thousands of tons of debris orbiting the Earth, the risk of collisions with operational spacecraft and satellites is ever present, jeopardizing the success of future missions and endangering the safety of astronauts. The proliferation of space debris also carries economic implications for the space industry and poses a threat to critical infrastructure such as the International Space Station. Addressing the space junk crisis requires a concerted effort from the international community. We must come together to develop and implement effective measures for tracking, monitoring, and mitigating the effects of space debris. This includes promoting global cooperation in sharing data and resources, enforcing existing regulations on space debris mitigation, and developing new technologies for actively removing debris from orbit. Technology, regulations, and responsible space practices will play a crucial role in securing the future of space exploration. By investing in innovative technologies for debris removal, designing spacecraft with built-in mechanisms for deorbiting, and implementing stringent regulations on satellite disposal, we can minimize the generation of space junk and ensure the long-term sustainability of space activities. It is imperative that we act now to preserve Earth's orbital environment for future generations of explorers. In conclusion, the space junk crisis presents a formidable challenge, but by working together and embracing sustainable practices, we can overcome this obstacle and unlock the boundless potential of space exploration.